Well, we're back here at the Hall of Science, and we're looking at the review for the plate tectonics test. And the one formula we need is speed or rate, and we've looked at that several times this year, and that is distance divided by time. So with that, let's look at the first question. Give a possible explanation and explain the differences in the angle of subduction from the diagram above. Uh, Essentially, we talked about this many times. It's a density of the ocean plate. The greater the density of the ocean plate, the steeper the angle of subduction. So if you look at these three particular ones here, the steepest angle is the middle one here, and this would have the greatest density. The shallowest angle of subduction, would be the bottom one, and this would have the least density of the three. And therefore, we talked about the volcanoes will be farther inland, and where it's the greatest density of the subduction plate, you would find the volcanoes closer to the shoreline. The next question is, refer to the diagram, draw the movement of energy, and we know that as you move to the core, it's much hotter, and we know warmer material rises, and as it rises near the crust or the surface of the earth, it cools down, and then it will fall back, and that is a convection current. And the third question here, it has describe the change in density. Well, as the warmer material will be less dense, that's why it rises, and as it cools, has greater density, so it falls back towards the outer core. Excuse me. Number 3, what's the name and classification of the rock that comprises the ocean floor? It's basalt, and that is mafic, contains magnesium and iron. And as we saw many times in many of the activities we've done, what happens to the density and age of the ocean floor as it moves away from the ridge? Well, as it moves away from the ridge, it definitely becomes older, and as it moves away from the ridge where the magma is breaking up through the crust, it's going to become cooler, and therefore also the density is going to become greater. The average rate, somewhere between 3 and 5 centimeters. I think if you put less than 10, I'd let that go. The evidence, we did a whole activity on that, and that's magnetic reversals. You graph that with a bar graph, and you looked at it also on a linear graph or horizontal graph, and magnetic reversals are evidence of seafloor spreading. Question number 4, the examples we used in class lectures, and I made quite a point of these. If we have a transform boundary, that was a San Andreas Fault out in California, one that goes through San Francisco. A continental converging boundary, I think I got a spelling mistake there, was the Himalayan mountains, where the Indian plate is really smacking into the Eurasian plate. And a continental diverging boundary, the East African Rift, or if you put the Red Sea, which we did an activity on, I also let that go. This number 5 is very similar to what we did in the problems that we did in class, and you did with the magnetic reversal activity. What is the rate of movement for plate A or B? Express your answer in centimeters per year. 1 kilometer equals 100,000 centimeters. Well, we know that the plates move at the same rate on either side of the ridge. So if this value from C to D is 300 kilometers, really we only got to take one side, and one half of 300 kilometers is 150. And so here we've got the age, 3.3 million years old, and we did this many times in class. We have 150 kilometers over, just write it as years, 3,300,000 years, and we know there are 100,000 centimeters that was given to you in 1 kilometer, and that's about 4.5 centimeters per year. Again, the key here to remember was the same thing happens on either side, and we did several problems like that. Let's see, this question, use the diagram above. Well, you can see that we have volcanoes here, we've got a subduction boundary, this has to be a continental plate, this is an oceanic plate, and so we have an oceanic continental subduction boundary. What oceanic feature is found? Again, oceanic, that's where your deep sea trenches are. We looked at several of those through the last 3 or 4 weeks. What causes the ocean plate to subduct? It has greater density than the continental plate. What's the name and classification of a rock that comprises the continental crust? It's granite, and it is less dense than the basalt. And the continental crust is granite. It's also felsic, containing feldspar and silicon. This problem, part C here, is very, very similar to what we did in class with the Hawaiian Islands and the Yellowstone. In fact, most of this problem we did as an activity in class. The first part is just to graph these points. And let's see if I got this here somewhere. And I guess this one didn't quite turn around, but you can see that we're graphing longitude is on the X and age in millions of years is on the Y. And we had to draw the line of best fit. A couple of questions that went along with this. As I scroll down here, we needed to fill in the table, measure distance in centimeters. And what we're looking at here is this distance from the Kilauea volcano to whatever island they're talking about here. So you'd measure that in centimeters, and you know 1 centimeter is 43. So 13.5 centimeters is 580 kilometers. The age in years, I'm going to scroll back up here real quick. The age in years was nothing more than, let's get this, putting these values in an approximate age in millions of years here. So that wasn't too bad to do. And I'm scrolling back down here. And so that was just filling in the table. And we actually did this problem a couple times in class. Which island, Hawaii Island, is the youngest? And we know the hot spot's right here. And so that is the island of Hawaii, which is the oldest. Well, the hot spots here, where the active volcanoes are, it'd be the one that's farthest away, and it's Kauai. Referring to the map in your graph, what's the relationship between the age of islands and their longitude? From your graph, the further west you get in longitude, the islands get older, because we know the Pacific plate is moving to the north and to the west, because this is the hot spot. And let's see, what's the inferred age? The inferred age of this, Noel, I guess that's how you pronounce it, you would get by using the graph. And we've done a few of those also. Which island does not seem to fit the pattern of the others? Anything that was farther west. And again, you could have picked this one here, would have worked, and that was fine. We'll predict now where the next volcanic island will form. Well, if we look at the map, it's going to be somewhere down here. As the plate moves from the southeast to the northwest, it's going to, the next one's going to form really right over the hot spot. But the plate's moving from a southeast to a northwest direction. Let's see what else we have here. As the distance west of Kilauea increases, the size of the islands appears to decrease. Erosion, as the water, as they move over the hot spot, the islands start to erode from the water. And also, it could have spent less time over the hot spot, and therefore you wouldn't have as much time for the island to form. And let's see, predict, we did that one. Calculate the rate. As we use the data, and number 9 I did down here for you. Very similar to the problem you did earlier. 13.5 centimeters, 43 kilometers per centimeter is 580 kilometers. The time difference between the two was 4.2 million years and about 13.8 centimeters per year. And we've done several problems like that in class. And again, I'll leave this up. If you got a particular question on any of these, don't be afraid to ask. And the retest will be very, very similar to this material here. All right.